So good evening, students. Anyways, it's not evening, it's almost afternoon, and I wish you all the best and a happy new year to all of you. I hope that your this year goes very well, and whatever plans you have for this year, or in case you have taken any resolution, all goes very smooth for you. Now, see, today, because it's a new year time, it's a new year day, so I'm not going to talk much about the subject, but yeah, if you remember, you talked about, like you saw my SN1 video and also SN2, which I have shared on my channel. So in SN1, I added two videos. One is just the basic, like first talking about substitution elimination and then starting with SN1. So that video you can see in my recommended video for this playlist. Like I have in this video, you will also find a recommended video. You can find it in the description. And at the same time, in SN1 continuation, the second video, so both the videos I have put it here in the recommended videos, you can see it. And in the conclusion video of the SN1, I just added one point that generally we believe that complete resmization takes place in SN1. So if you see the video very well, I promised and I said that I will bring a very short video to just talk about the SN1. In SN1 also, why inversion product is slightly more dominant than retention product. So if you see this part, like for example in SN1, okay, so in SN1 I said that the first step, let's say if you have alkyl halide like this, so in the first step what happens, which is a RDS or formation of a cation. So in this case you get a planar carbocation. If you want me to show properly, I will show properly so that it looks sp2 hybridized. So this is a cation, and then obviously the leaving group has to leave. So this is the rate determining step, right? And then in the second step, obviously the nucleophile, the attack of the nucleophile, which can happen from either of the side. It can happen from front also, or it can happen from the back also. So this back talks about inversion, and the front talks about the retention. Now both this happens in equal probability. That's why we say that it is a case of complete resmization. Why we say it is a case of complete resmization? Because inversion is equal to retention, okay, as far as probability of attack of nucleophile is concerned on the planar carbocation. Very simple and very straightforward point, which I have added in the regular SN1 video also. Now if you remember, this video is mainly about why in SN1 inversion product generally dominates over retention product, and in which case, okay, so this is the primary question about which the video is all about. And I said that inversion dominates over retention, but why? That we will see. And in which case this is 100% true. That also we are going to discuss and close today. Okay, so I'm just erasing this. Like if anybody is writing anything or taking notes, you can always have the option to pause the video and take. And secondly, like if you feel that my video is slightly on the slow side, if any good student is there, so they can always have the privilege to see the video in 1.5x or 2x, those options YouTube has given you, right? Now I'm heading to the main part which we are here for, like this question which I'm not erasing. Now see what happens. Like for example, if I have a RX, I'm taking alkyl halide. Now this leaving group starts to leave, right? That means you are on a verge to form the carbocation. But is it immediately happening? No. Why? Because Formation of the cation is a rate determining step, and it's a slow step. We know that. We know the kinetics part. Now in this, if you see, first is like R plus and X minus is formed, but these two ions are not very far from each other. Okay, we call it intimate ion pair. Okay, so once this intimate ion pair is formed, after that further separation happens due to solvent. Okay, or you can also say due to the solvation ability of the solvent, or due to the dielectric property of the solvent. So in that case, what happens? The solvent molecules comes in between and individually interacts with the units of cation and anion. So you can show it like this. Let's say this is the solvent molecule. Okay, so this is called solvated ion pair. Okay, you can call it solvated ion pair. And after that, R plus and X minus is significantly farther. Okay, these ions. Okay, these ions are significantly farther at the above instant, due to enough of solvation taken place. Thus, okay, due to enough of solvation taken place at this point of time, right? Now if you see this as the stage 1, okay, this as the stage 2, and this one as the stage 3. So based on these stages, what are our observations or what are our conclusions? That in stage 1 and stage 2, if I write it like this, in stage 1 and stage 2, the anion, in bracket you can write the leaving group, is still in the vicinity of the cation, due to which nucleophile, if approaches from the same side of the anion or of the leaving group, experiences significant repulsion. Due to which enough, or you can just erase this word, due to which inversion product dominates. Because nucleophile will not experience any repulsion from the anion if it is coming from the opposite side, and that is what is the context of this video. But in stage 3, because the anion is significantly far now, right? Significantly far now from the cation, so no such repulsion will be experienced when the nucleophile approaches, because anyhow the nucleophile will approach the cation, and if the anion now at stage 3 is very much far from the cation, then it is not going to impact the repulsion, or it is not going to repel the nucleophile, because anyhow nucleophile approaches the cation, and if the anion is closer to the cation, then it will cause repulsion with respect to the nucleophile. But that is not the case in stage 3. So in stage 3 what happens? Ki nucleophile now has equal probability to attack from either of the side in the cation, and that is what is retention product and inversion product is equal, has equal probability to be formed. And in stage 3 we have complete racemization, okay, which we generally say in most of the basic level books. कि complete racemization happens, so we believe that the nucleophile is attacking the cation in stage 3 when the cation and anion has separated far enough, right? That is the basic point. But in these two cases, in stage 1 and stage 2, because inversion slightly dominates more over retention, that's why we say that in either of the stage 1 or stage 2, we have partial racemization. Okay, so the conclusion is कि stage 1 and stage 2 has partial racemization okay, and stage 3 has complete racemization. And if nothing is mentioned in the question and they have simply written SN1, so we always assume that it is stage 3. Okay, so we never, in basic level, in 11th, 12th level, in JEE NEET level, we never talk in detail that the question is asked on the basis of stage 1, stage 2 or stage 3. So for question solving, you can stick to complete racemization. For question solving, you can stick to stage 3 assumption. Until and unless the question is highly specific, which is generally not the case in the 11th, 12th level exams. But if it is so, they will mention it clearly. Okay. So anyways, with this thought process, I hope the concept is clear. Let me tell you one thing. We also have a habit of like learning every day and implementing the same in form of this so that student gets the best possible content in least possible cost or sometimes even free, right? Because we believe in our work and we try to teach as much as possible so that we can benefit you in some form or the other, right? And the second thing is Happy New Year to all of you, and I believe that your all the wishes comes true, and I'll not have a very illogical wish for any of my student who is going to watch this video. I just want to add one thing ki don't chase life like most of us do. Like we believe that if we crack an exam, our life will be successful. If we don't crack an exam, our life will be waste. So that is not the case, right? Everybody is learning every day. And the one thing I want to add, that whatever you are now in 2022 now, try to be better, let's say in February 2022 or March 2022 or in the upcoming years. Try to become better by every passing day and do something in life so that you can track your progress. Okay, that is what which is going to take you somewhere. It is not about whether you will be able to crack IIT or NEET. That is just a part of it, a small part of it. But in life overall, if you see, like generally there are many students or many people who questions me that, sir, if you are into teaching, then why you do other things? For example, I also write a book. One of my book is available in Amazon. And then I also do bodybuilding. I'm a nutritionist. But that doesn't matter. Okay, I try my best to make sure that I progress in every possible dimension and become the best possible version of myself. And that is what I want you to be as well. Okay, never compare yourself with others because you will be demotivated in some context or the other. So anyways, all of you try to be the best possible version. Again, I wish you all the best for all your perspectives, or you can say whatever plans you have in life. I hope it goes well. And just keep supporting the channel, and also make sure that if you like the content, you just share it with your friends as well. Okay, so Happy New Year once again. Thanks a lot. Bye.